Tomorrow will be better. An 85 kg man pushes a crate up a ramp inclined at 20 degrees to the horizontal. He exerts 500 Newton on the crate in a direction parallel to the plane, making the crate move 4 meters at constant speed. Find the work done. Follow me, dear friends. In this particular question, one thing we are supposed to take into account is that the man is applying a force not just to move the crate upward, but to move his own body upward. So these are the two things to take into account here. If you quickly draw some sort of a free body diagram, you will have something like this. This is the man here, and then this is a crate here. The question says that he's exerting 500 Newton already in a direction parallel to the plane. So this is the only possible direction for this force. He is exerting this force here, but he also has a weight which acts downward. His muscles are exerting another force to push himself forward. Now, the minimum force which this man requires to push himself upward without the crate is equal to the downward force which wants him to come down. And this downward force here, dear friends, is a component of his weight, which experimentally has been proven that if this is 20 degrees here, then this will be mg sine of 20 degrees. We are not talking about the mass of the crate, but the mass of the man. In other words, since the question also underlines that it's at constant speed, therefore there is no acceleration, it means that the minimum force he requires to push both himself and then the crate at a constant speed is this 500 Newton plus this mg sine 20, which is required to overcome his own weight first of all, right? So we know that work done equals to force times distance. We already have the distance, which is 4 meters. Now, what is the force in this case? We will say, but for this situation, the force is going to be equal to what here? The force will be equal to the 500 Newton, which is applying, plus mg sine theta, m, which is 85, times g 9.81, and then times sine of 20. Now, work done, therefore, we will say work done will be equal to all of this force here times 4 meters. And if you correctly punch this, we will have 3.14 times 10 to the third. Work done is expressed in joules. So this is the final answer. Tomorrow will be better.